Here we have a derivative problem on velocity and acceleration. Okay, let's go with the information. The distance x meters described by a car in time t seconds is given by x equals to 3t cube negative 2t square positive 4t negative 1. Determine the velocity and acceleration when t is equal to 0 and t is equal to 1.5 seconds. Okay, to determine the velocity and acceleration for the given timings, t is equal to 0 and t equals to 1.5 seconds. So first we have to find the velocity function and acceleration function. Okay, to get the velocity function, what I need to do is I have to find the derivative of the given position function by x with respect to time. That is v equals to dx over dt. Okay, so velocity v equals to, so already we know that x equals to 3t cube negative 2t square positive 4t negative 1. We can plug in this expression for x over here, that is d of 3 times t cube negative 2 times t square positive 4t negative 1 over dt. Okay, now let's find the derivative of this expression with respect to time. Okay, so here 3 is a constant multiplied by the variable. When I find derivative, if there is a constant multiplied by the variable, I have to keep the constant as it is. Now I can find the derivative of this t cube using the power rule of derivative. So what is the power rule of derivative? That is, I have to bring this exponent 3 in front of t and subtract 1 from the exponent. That's a power rule. That is 3 times. So I bring the exponent 3 in front of t and I subtract 1 from the exponent. If I subtract 1 from 3, I am getting 2. So this is a power rule of derivative, negative. Again, 2 is a constant multiplied by the variable. So let's keep the constant 2 as it is. So we can use the power rule again to get the derivative of this t square. So for that, I have to bring this 2 in front of t. Then I have to subtract 1 from this exponent 2. Then I'm getting the exponent 1. So whenever the exponent is 1, we don't have to mention. So simply we can write this one as t positive. 4 is a constant multiplied by the variable. So we can keep the constant 4 as it is. And when I find the derivative of this t with respect to t, I'm getting 1. So negative, and it's 1 is a constant. The derivative of a constant is 0. Okay, now let's simplify this one. So 3 times 3 over here is 9 times t square, negative 2 times 2 is 4, t positive 4. So now I got the velocity function over here. Okay, now what I need to do is I have to get the acceleration function. So for that, to get the acceleration function, what I need to do is I have to find the derivative of the velocity with respect to time. So actually, velocity represents the change in the position of the car with respect to time. So acceleration represents the change in velocity with respect to time. So that's why I find derivative of velocity with respect to time, that is dt. So a equals to d of, and for this we already know that 9t square negative 4t positive 4. So we can plug in this expression for v over here. Then I'm getting d of 9t square negative 4t positive 4 over dt. Okay, now let's find the derivative of this one. So here the constant 9 is multiplied by the variable. We can keep the constant 9 as it is. When I find the derivative of this t square using the power of derivative, I am getting 2t negative 4 times the derivative of t with respect to t is just 1. And this is a constant 4. The derivative of the constant 4 is 0. So then I'm getting a equals to 9 times 2 is 18. T negative 4 times 1 is 4. Now I got the acceleration function. Okay, now I got the functions for both velocity and acceleration. So now to get the velocity and acceleration at t is equal to 0 and t equals to 1.5, what I need to do is I have to plug in t equals to 0 into the velocity function and acceleration function as well. And also the same thing, I have to do this for t equals to 1.5. Okay, let me do this stuff on the next page. Okay, to get the velocity at t is equal to 0, we have to plug in t is equal to 0 into the velocity function we have over here. Okay, let me do it. Then v equals to 9 times 0 square, negative 4 times 0, positive 4. Then I'm getting v equals to, so 0 square is 0. When 0 is multiplied by 9, it will become 0. Negative 4 times 0 is 0, positive 4. And I'm getting v is equal to, when I simplify this one, I'm just getting 4. So what unit should we write for this v? Okay, already we got the velocity by taking derivative of the position function x with respect to time. So the position x was given in meters, and here the time is given in seconds. So we have the unit of the stuff we have in numerator is meter, and the unit of the stuff we have in denominator is seconds. So the unit of the velocity has to be meter per second. Okay, now let's find the acceleration when time t is equal to 0. For that, we have to plug in t is equal to 0 into the acceleration function. Okay, let me do it over here. That is a equals to 18 times 0, negative 4. Then I'm getting a equals to 18 times 0 is 0, negative 4. Finally, I'm getting a equals to negative 4. What should be the unit of the acceleration? Actually, we got acceleration by finding derivative of velocity with respect to time. Okay, so this dv over dt can be as d over dt times v. Already we know that v equals to dx over dt. So we can plug in this dx over dt for the v over here. So then I'm getting a equals to d over dt times dx over dt. So that is here to get the acceleration, I find the derivative of the position function twice, and both the times I do derivative with respect to t. So it can be written as a equals to d square x over dt square. That is to get acceleration, we find the derivative of the position function two times, and both the times we do derivative with respect to time. Okay, so how can we write unit for this one? Already we know that the unit of the position function x is meters, and the unit of time t is seconds, but we have t square, so we have to write meter per second square. So this is a unit of acceleration. So here when t is equal to 0, the acceleration is negative 4 meter per second square. Okay, now let's find the same velocity and acceleration when time t is equal to 1.5. For that, I have to plug in t is equal to 1.5 into the velocity function and acceleration function as well. Okay, first let's find the velocity when t is equal to 1.5. So then I'm getting v equals to 9 times 1.5 the whole square, negative 4 times 1.5, positive 4. Okay, v equals to, so when I take square for 1.5, I'm getting 2.25. When 2.25 is multiplied by 9, I'm getting 20.25. So 4 times 1.5 is just 6, positive 4. So when I simplify this numerical expression, I'm getting 18.25 meter per second. Already we know the unit for velocity. Okay, now let's find the acceleration when t is equal to 1.5. So that is we have to plug in t is equal to 1.5 into the acceleration function. That is 18 times 1.5, negative 4. So then a equals to, when I multiply 18 and 1.5, I'm getting 27, negative 4. Then I'm getting a equals to 23. So already we got the units for acceleration, that is meter per second square. Okay, now I got both velocity and acceleration when time t is equal to 0 and t is equal to 1.5. When t is equal to 0, the velocity is 4 meter per second, and the acceleration is negative 4 meter per second square. When t is equal to 1.5, the velocity is 18.25 meter per second, and when t is equal to 1.5, the acceleration is a equals to 23 meter per second square.